Assalamualaikum and good day. My name is Muhammad Nazmi bin Mizan. My metric number is 182229. And my final year project title is Torrefaction of Empty Fruit Bunch by introducing superheated steam. And my supervisor is IR Dr. Samsul Izhar bin Siajam. Okay, so based on my FYP title, there are three important keywords. The first one is torrefaction. Torrefaction is thermochemical conversion method where biomass is subjected to thermal heating in the absence of air, typically in temperature range of 200 degrees C to 300 degrees C. The second one is empty fruit bunch, EFB. EFB is a solid waste from crude palm oil mills. It is a bunch without the palm fruit and produced during threshing of fresh fruit bunch, FFB, to separate the palm fruit from the FFB. The last one is superheated steam. Superheated steam occurs when heat energy is added to saturated steam that is not in contact with liquid. When the heat energy is added, the steam temperature is increased above the saturation temperature. It is also referred to as dry steam, meaning it contains no water droplets. So now we jump into introduction. Energy consumption in Malaysia is mainly based on fossil fuels such as natural gas, coal and petroleum. Hence, over-dependent on fossil fuel for primary source of energy supply has led to global energy crisis, increased greenhouse gases emission and also decline in fossil fuel reserve. So, we need an alternative ways to substitute the uses of fossil fuels. So, one of the alternative is renewable energy. So biomass is one of the most potential renewable energy in Malaysia due to its carbon neutrality, sustainable and was available, stated by Petinrin and Shabaan 2015. So Sumati et al. 2008 state that Malaysia is one of the main oil palm tree producer generating high amount of agricultural waste. Thus, the availability of large quantity of oil palm biomass in Malaysia is promising for future generation of renewable energy. So, biomass waste from the old palm plantation are, for example, empty fruit bunch, EFB, mesocarp fiber, MF, palm kernel shell, PKS, oil palm from PF, and also oil palm trunk, OPT. The treatment for all these biomass have been neglected and threw away the biomass into landfill without any treatment that may lead to increase the greenhouse gas emission which can pollute our environment. So there are some ways biomass can be treated through thermochemical conversion, biochemical conversion and extraction of oil. Among those, thermochemical conversion process is among the best techniques because it may lower the emission of dangerous toxic, improve thermal efficiency and other high value fuel by Chen et al. 2011. So EFB is the most abundant oil palm waste and most targeted oil palm biomass because it could be utilized to produce bioalcohol, solid fuel, pulp and many other value-added products. So for the last 5 years, the estimated amount of EFB generated every 6 months is about 10 million tons worth per half year by Al-Juburi Ahmad 2013. Superheated steam also has been used as a treatment for biomass in liquefaction for fuel, carbon activation for absorbent materials and also torrefaction, which is a mild thermal process with temperature range from 200 to 300 degrees C to improve the fuel properties of the biomass. So in this project, empty fruit bunch is selected as the raw materials will undergo torrefaction process by introducing the superheated steam and process temperature range from 200 to 300 degrees C. So now literature review regarding to the FYP project. From Look et al. 2013, EFB has no non-uniform shape and low bulk density and contains a high moisture content ranging from 60 to 70 weight% on a wet basis. In crude palm oil mills, usually a boiler system is used to supply the thermal and electrical energy required for milling process, and solid waste were used as combustion fuel, but only selected one is used, especially those which are easy to burn and do not require further treatment. This lead to failure to use EFB due to its disadvantages, in particular due to high moisture content. Abu Bakar et al. 2010 said that normally EFB are recycled as much in planting areas to prevent soil erosion and maintain the nutrient cycle, but there are post-problem in its utilization, such as high transportation costs, greenhouse gas emission, and labor costs. Torrefaction process on EFB, empty fruit bunch. In recent study of the torrefaction process on EFB, Muhammad Hisham Sulaiman et al. 2016 observed that increase in torrefaction temperature resulted higher calorific value and carbon content also increased. Increase of calorific value was due to the enrichment of carbon content of the EFB after torrefaction. So based on the figure that show the effect of temperature that will increase the calorific value and also carbon content, because calorific value and also carbon content is the important parameter to show that EFB had been improved while undergo the torrefaction process. In another study made by Turaya Taim and Roida Abdul Rashid 2016, focusing on the proximate analysis, volatile matter of EFB emits a decreasing trend as the temperature is increased, and Chen et al. 2014 also reported the same trend based on the figure 2 that can be referred to. So volatile matter and fixed carbon are two important parameters of solid fuels, whereby high VM means that the fuel is more reactive but has less calorific value, which is not good based on Chen et al. 2014. Fixed carbon is increasing when temperature increase, means that the fuel is less reactive but has high calorific value based on Chen et al. 2014. So in this project we need to make sure that the volatile matter is reduced after undergo the torrefaction process, and the fixed carbon need to be increased to make sure that the product is in a good quality. So we now jump into superheated steam on biomass. Superheated steam on biomass is a pre-treatment process that opens up the fibers and makes the biomass more accessible for subsequent processes such as fermentation, hydrolysis, or densification process. Biomass are composite material with high mechanical strength, and the major component are cellulose embedded in a matrix of lignin and hemicellulose by Fengel 1983. So it also discussed superheated steam is also discussed as a pre-treatment process for the production of solid biofuel to increase the calorific value of the biomass. A recent study by Lam et al. 2011 suggests that superheated steam of wood result in a material with favorable fuel properties, high heating value, low moisture absorption, and good pelletizing properties. So next is problem statement regarding to the project. The abundance of empty fruit bunch produced from oil palm industry has created a major disposal problem, and throughout the year, if the waste production keep increasing, the disposal will be no longer affordable. But actually, the solid waste can be used for boiler in palm oil mill, but for EFB, due to its disadvantage, in particular due to high moisture content, it leads to failure to use as the feed to the boiler in the palm oil mill. So some drawbacks from EFB is high moisture content, low energy density, high hygroscopic nature, low heating value, soot formation during combustion. Therefore, it is normally recycled as much in planting areas to prevent soil erosion and maintain the cycle by Abu Bakar et al. 2010. High transportation cost, greenhouse gas emission, and labor cost pose problem is utilization. So pre-treatment via torrefaction process by introducing superheated steam can improve the FB and eliminate all the drawbacks, which then can be used efficiently. So the objective of this project is to improve the drawbacks of empty fruit bunch and to create solid fuel with enhanced characteristics via torrefaction process by introducing superheated steam. Second one, to analyze the characterization of solid fuel produced based on the proximate and ultimate analysis comparing with the original FP. The third one is to compare the calorific value of the solid fuel produced with the industrial co-ranking. The last one is to select the optimal operating condition of the process by varying the operating temperature. Significance of this study is to observe the effect of introducing superheated steam into the refrigeration process to eliminate drawbacks from the original FFP. Second one is learn the effectiveness of this treatment to the original FB to become an efficient solid fuel with high heating value. The third one is to identify the quality of the torrefied EFP with the industrial co-ranking. So this is the machine that will be used during my project, that can call it as rotary kiln carbonization furnace. So in methodology of the project, we divided into three. The first one is preparation of the sample, where EFP are collected from palm oil mill located inside Dabi plantation Pulau Keri, and then it will cut into small size. Then EFB is oven dried at 105 degrees C for 24 hours to remove the residual water remaining and store in closed airtight plastic bag. Okay, the next one is rotary kiln carbonizer setup, where steam generator at 200 degrees need to be connected with water supply and supply it at a flow rate about 1.0 ml per meter using pump. So right furnace must be connected to steam generator to add heat energy to the saturated steam to become superheated steam. Superheated steam then will flow into the rotary kiln where the FV will be torrefied and will release the water matter, tar and gases. Component release will flow into left furnace to make sure no condensation occur before entering the condenser system. The last one is torrefaction process of FB, where prepared sample will put in the rotary kiln. Actually, it's a reactor that placed in the rotary kiln furnace, and torrefaction temperature in the reactor need to be made sure constant at this for temperature. So the processing time for each process is set to 60 minutes. This is the time course of temperature, where the rotary kiln carbonizer furnace has its own temperature controller, and we will use the controller to set all the operating temperature during the experiment. So after we got the torrefied product, we need to analyze it within the four categories. The first one is percentage yield of the product, where the weight of the FB will be determined before and also after the process, and the yield of the torrefied polymer will be calculated. The second is ultimate analysis, where determination of the weight of carbon, hydrogen, nitrogen and sulfur will be determined using CHNS analyzer. The third one is proximate analysis, where we analyze the percentage of moisture content, fixed carbon, volatile content and also ash using thermogravimetric analyzer TGA. And the last one is calorific value, where we analyze the high heating value, or we can call it as calorific value of the torrefied product using bomb calorimeter. Material and apparatus. So this is the material that will be used. The first one, empty fruit bunch. Second one is deionized water for the steam generator. The third one is grease for the rotary kiln carbonizer furnace for the compartment. Apparatus used is rotary kiln carbonizer furnace, oven, spana sets, glove, conical flask and also airtight plastic bag. So this Gantt chart showing the progression for semester 1 2018 and 2019 based on title selection, literature review, supervisor meeting, thesis writing, proposal presentation, video presentation and also lab experiment. So these are the references that are being used during this whole semester for this project. That's all from me. Thank you.